Okay, this is a today's topic: physical design of IoT system. What is the physical design of IoT system? The physical design of IoT system refers to you will know something about the different IoT things as well as the IoT protocols here. Here, what are the different things? What are the protocols here? Here comes to the things. If it comes to the things, here is a thing is a IoT device. Here IoT device are a node device. That means which having the identities. That means each and everything having the some IP address. And then the this kind of devices performs the remote sensing capabilities. That means it will sensing in the sense it will retrieve the information from the environment and then activating capabilities. Here that means activating capability in the sense it takes the electrical form of data and converted into um, this physical parameters. That's called here activating capability and then monitoring capabilities. These are all the properties of things of the IoT system here. Here comes to the second important one. Here is a IoT protocols here. The IoT protocols, that means among the things you will establishing the communication by using these protocols here. The protocols here comes to the things here. What is the thing here? The thing is a IoT device. Already you know very well about that. The thing having the identities. That means it's having the IP address. It's having the remote sensing capabilities, activating capabilities. The activation in the sense just like a motor. The motor takes the electrical form of data and then converted into that means it gives a water, that is a activating capability motors. Here the IoT device can exchange the data from one device to other device or one device to other applications directly or indirectly. And then these IoT device can collect the data from servers. That means the servers are placed in a cloud. That means from the cloud here these IoT devices collecting the data and then process the data locally and then send data to centralized server or cloud based application. That is another property of IoT device. And then performing some task locally and other tasks within a IoT infrastructure based on a temporal and spatial constraints. That is some information about the IoT system. Here this IoT device consists of several interfaces. Here this device is having a different kinds of interfaces are there. What are the different kinds of interfaces here? Some of them are IoT interfaces here for sensor and actuators. Some of them are interfaces for the internet connectivity. Some of them are memory and storage interfaces. Some of them are video and audio interfaces. But why? Because here in order to connecting the IoT device with another devices, you have a different kinds of interfaces here. Here these interfaces connecting via wired or wireless. Here that means you may connect these interfaces via wired or wireless. Here these are all different kinds of interfaces in a IoT system. Here for one is that means these are all IoT device interfaces. Connectivity devices, USB host, USB in the sense universal asynchronous receiver or transmitter. Here and then RJ45 or Ethernet. These are all connectivity interfaces. That means for connecting one device to another device, one IoT device to another device, IoT device, you required some interfaces. These are all connectivity interfaces. Processor interfaces, CPU, audio and video interfaces. Here HDMI, 3.5 mm audio, RCA video, and then memory interfaces, NAND NAR, and then DDR1, DDR2, DDR3, and then graphical interfaces are there. Some of them are GPU, storage interfaces, SD cards, MMCs, SDIO, and then come to the another kind of interfaces. Here is a input output interfaces for the sensor and actuator, UART. One is a UART, other one is a SPI. Here UART in the sense universal asynchronous receiver or transmitter. SPI in the sense serial peripheral interface. Serial and then I2C and then CAN. These are all different interfaces. That means we will discuss one by one next session. Here, one is a USB host. What is an USB host here? USB host is a connectivity, the connectivity interface. Here, USB host is a system that connects the multiple USB clients. Here, it will clients the, that means it will connect the multiple USB clients here. For example, PC is a USB host. Here PC have the some USB host and it connect to the multiple USB clients like a mouse. That means from the PC having the different kinds of USB host. That means you will connect the mouse, you will connect the keyboard, you will connect the mass storage devices. Here, those are all different kinds of devices. Another important one here is a RJ45 Ethernet port. Here, RJ45 Ethernet port. This is also a connectivity device here. Here, what is this Ethernet port here? You can connect an Ethernet cable or USB. What is the necessity of this port? Yeah. What is the necessity of this RJ45 Ethernet port here? You can connect the Ethernet cable or USB Wi-Fi adapter to provide internet connectivity here. And then comes to the another important one here is a HDMI. Here, audio or video interface. Here, what is an audio or HDMI? What is the necessity of HDMI here? It provides both video and audio output here. That means you can connect the Raspberry Pi to monitor using HDMI cable. Here, that means for monitor that have the DVI port, but no HDMI port here. That means olden days you are using the HDMI ports. Here, for example, in our projector also you are using for connecting to the laptop, you will use a HDMI cable. Here, that is olden days. HDMI port information is there. Here, that is a HDMI connectivity. And then other one is a composite video output. Here, RJ jack. Here, what is an RJ jack? RCA jack here. The RCA jack is a video or audio interface. Here, that means composite video output. Here, that means it comes with the RJ jack, supports both PAL NTSC video output. That means it supports the video outputs. RCA jack can be used to connect the old TVs like this. Here, these are all RCA jacks. Here, other one is a audio output here. Here, what is an audio output here? Other video interface here. 3.5 mm audio input jack. Here, what is the purpose of audio input jack here? It is for providing the audio input to the old TVs. Here, both RCA jack and then 3.5 mm audio input jack also used to old TVs. That is another interface here. Here comes to the input and output interfaces. Here SPI. Yeah, SPI is a one type of input and output interface. Serial peripheral interface is a synchronous serial data protocol used for communicating with one or more peripheral devices. Here SPI, that means the SPI, you may use the SPI in a Raspberry Pi device, and then I2C, the I2C interface pin on a Raspberry Pi. This also, this kind of pin also available in a Raspberry Pi, allows you to connect the hardware module. Here, what is the necessity of I2C? I2C used to allows the hardware module for connecting the hardware module, and then I2C interfaces allows a synchronous data transfer. Here, and then some of the IoT devices collect data from the onboard or attached sensor. And then today's many kind of IoT devices, the cloud servers available for the IoT system. Here, so that means you have a different kinds of devices are there. Here, IoT devices includes computer devices, software, wireless sensor, actuators. That means so many different categories of IoT devices available today here. Here, these IoT devices are connected over the internet and enables the data transfer among the objects and our people. That's can't hear anything here. Here, some of the devices here. Here, some of these devices existed here. Here, what is the necessity of these devices here? For example, computer device is a one type of IoT device. Software is a that means software, wireless sensor, activators. These are all also one of the IoT devices. Here, these devices are categorized like this here. Here, some of the accessories devices. Here, some of the accessory devices. Here is a sensors. Sensors in the sense takes a input from the environment. Here, the physical parameters takes a physical parameters. The physical parameters are temperature, humidity, here heat. Like that, you will take the input and then convert it into electrical form of data. That is a sensors here. Just like our human body having the different sensors, six different sensors are there. Here activators. Here, what is an activator work here? The activator work here is a takes a electrical form of data converted into physical parameters. Here, just like that means, for example, our motor is a activator. The activator takes the electrical form of data and then convert it into water. Here, similarly switches here. That means connected to the different devices, displays. Here, monitors, relays. Like this, you have a different accessories are there. Here, some of the embedded system based IoT devices. Here, some of the embedded based IoT system devices. Arduino is a one type of device, and then Intel Galileo, Raspberry Pi, Cubio board. Here, these are all embedded system board IoT devices. Other kind of IoT devices here is a wearable devices. Here, Google Glasses, Samsung Gear, and then Fitbit. Here, like that, you have a different kinds of IoT devices are there. The first one here is a sensor. That means you will discuss some of the things abstract view. In the abstract form, you will discuss the some of the. Here, what is a sensor here? The sensors look like this. Here, sensor is a device that reads the surrounding temperature, humidity, light, air quality, and then control, air quality control. Like that, it takes some different form of data. Here, nowadays, you have a different types of sensors available, n number of sensors available. Humidity sensor, light sensor, that means air control sensors. Like that, we have a different types of sensor available for reading the data. Here, the sensor transmit the data over the network, or that means this is a one type or different types of sensors. Here comes to the Arduino device. That means you will discuss later about the clearly about the Arduino device. Here, what is the Arduino device? Arduino devices are microcontrollers, or the microcontroller kit for building a digital devices that can be sense or control object in a physical or digital world. Here, that means this type of Arduino devices available for what is the purpose here? These are all just like some computer, what's as a mini computer. Here, some of the Arduino boards includes USB. That means universal serial bus used for loading programs from the personal computer. But that means this program Arduino programs are there. That means these are all different programs developed by using C++, like that. This is a something about the Arduino kit. Here come to the Raspberry Pi. Raspberry Pi is a one of the embedded hardware device. Here, Raspberry Pi IoT device. Raspberry Pi is a low cost mini computer. That means by using Raspberry Pi, you will that means you will convert your TV into computer. That is a main advantages here. That means if you have the monitor, that monitor automatically converted into computer. Here, the low cost mini computer with the physical size of credit card size. It's a just like a credit card size here. Here, the Raspberry Pi runs on different types of Linux platform here. Why I called it as a Raspberry Pi? Raspberry Pi in the sense it supports the Python programming. Here, Pi here, Pi indicates the supports the Python programming. Here, it perform all tasks that normal desktop computer. Here, whatever may be the operation performed by the ordinary laptop or computer, those operations performed by the Raspberry Pi. Here, that means Raspberry Pi allows a interface sensors, activators, like that. Here, different kinds of pins are there. That means here you have a different pins. Here, USB pin, HDMI pin, USB power, SD card. That means in the back side, you may insert the SD card here. Here that means GPIO headers, like that it's having the different parts are there. That's called here Raspberry Pi. You will discuss later about clearly about the Raspberry Pi. Here, what is a Raspberry Pi? What are the pins of Raspberry Pi? What are the interfaces in Raspberry Pi? And then what are the components of Raspberry Pi? And then how can you connect this Raspberry Pi to our system? And then how can you do the programs by using Python, by using Raspberry Pi? You will discuss later about that information, but you will know a abstract form of Raspberry Pi. Here coming to the Intel Galileo. Here this Intel Galileo is the board here includes a different parts here. The Intel SoC processor, it's having some processor, and then 256 MB RAM, and then the multiple parts. The multiple parts and the supports this Intel Galileo supports a Arduino device. Here for supporting the Arduino device, you will use this one. And then Samsung Gear Fit. This is also a one type of IoT device here. Here, this what is this Samsung Galileo tip here? That means water residence watch, this one. That means with the fitness track and then futures, like that, for performing different alerts, emails, text messages. Here that means you will receive the different kinds of alert messages, emails, text messages by using this kind of Samsung watch. Here coming to the next one is a Bluetooth low energy BLE, intelligent beacon. Here what about this one? Here is a, here it is used to track the object location at a real time. Here in the real time here, that means you have a certain persons are there. I want to know, I want to, where is that person? Here it will track the a particular person location. Here the many companies use to track the location of employee or assets, the patients, like that. More real-time information for tracking these more time information, you will use a this BLE. That means this serves focus on the manufacturing, retail, healthcare services. That means in the healthcare services you will use a this BLE. Here one, this is a one of the device. Here those are all different devices, IoT devices. This is a these are all different devices you will use real world. Here coming to the properties of IoT devices. Here, what are the properties of IoT devices? The IoT devices perform different properties, sensing properties, and then send and receiving data, analyzing, controlling property. These are all four different properties performed by the any IoT device here. Here, the IoT device, if you take the Arduino device or Raspberry Pi, any device here. Here, the any device performing the device here. What is the sensing here? Sensing in the sense it takes the input from the surrounding environment here. Here takes the input from the surrounding environment, that is in the form of temperature, movement, appearance of the things. Here that is called here sensing. That kind of capabilities having this IoT device. Here other property here is a send and receive data. Here what is the IoT device? The IoT device can receive data or can send data to the different servers or in a internet. Here via internet, here you can perform in sending and receiving data. Another one is here is analyzing. Here we will perform the analysis, data analysis. Why? Because the IoT device is always generating the data. Here you will perform analysis. Here how can you for the data? You will perform the data analysis, explanatory data analysis. Here for example, how many rows for the system, how many rows in a data set, how many columns in a data set, and then what are the missing information in a data set, how can you fill those missing information in a data set, and then how can you process the data. That kind of information analyzed these IoT devices. Other one is a controlling. Here controlling the sense, here IoT device may control the many endpoints here. That means you have to control the many endpoints. Otherwise, the IoT device themselves communicate with the others. Other and endlessly leads to the system failure. If IoT device not having any control on the endpoint here, the system may failure. That means it will happen, the system failure. That is the first thing. In the physical design, the first information here is a IoT devices. Here coming to the second information. The second component in the physical design here is a IoT protocols. Here, what is the protocol here? Here, the protocol here is a set of rules and conventions. Here, it's having some certain kinds of rules. Here, what is the necessity of these rules? Here, communicating from one device to another device. Here, it is establishing the different kinds of rules. Not only rules here, you should include the conventions. Here, the IoT protocol helps to establish a communication between the IoT devices and cloud servers. Here, it is establishing the communication with the different IoT devices, having the not only IoT devices and then servers. Here, it helps to send a commands to IoT device and receive data from the IoT device. This is some information for establishing a communication with the one device to another device. You require different protocols. Here you have the protocol architecture. This one, the physical design architecture. Here, what is the physical design architecture? The physical design architecture consists of link layer protocols. Here, these are all our link layer protocols here. 802.3 Ethernet, and then 802.1.6 Wi-Fi Max, 802.11 Wi-Fi, 802.15.1.4 LRWPAN, and then 2Z, 3Z, LTE cellular. And then coming to the network layer protocol. In the IoT system architecture, IP version 4 network layer protocol, IP version 6 network layer protocol, and then 6 LOWPAN. This is the advanced version. That means it is a successor of the IP version 6. That is a network layer protocol. These are all three different protocols available. Coming to the transport layer protocol. The transport layer protocol, UDP as well as the TCP. Here, transmission control protocol, and then user datagram protocol. Here comes to the final one. Here is a application layer. Here, the architecture of IoT system divided into 4 layers. Here in the 4 layers, it's HTTP protocol. In the application layer, you have HTTP protocol, COAP protocol. These are all protocols applicable in a IoT system. That means FSocket protocol. These are all different kinds of protocol. The link layer protocol. Here, just like the architecture, just like a OSI reference model or TCP/IP reference model. In the TCP/IP reference model, having the 4 different layers, like a OSI reference model having the 7 different layers. Here, just like it's also having the different layers for communicating one device to another device. Here, these are all different layers here. The link layer protocol. First, we will discuss about the link layer protocol. Here, Ethernet, Wi-Fi Max, and then cellular. Here, what is a link layer here? Here, before knowing about the different protocols, the link layer protocols, you have to know about the link layer. Here, what is a link layer here? How data is physically sent over the network's physical layer or medium. Here, you are transferring the physical in the link layer. You are transferring the data via medium. Here, the medium may be a cable or wireless or others or radio wave. Here, you will transfer the data from one device to other device with the help of some medium. That is called here link layer. Here, the link layer determines how packets are coded or that means how transfer. That is done by using this kind of link layer. Is it clear? The link layer is main purpose of link layer here is a medium. That means with the help of a medium, you will transfer in the data. That is the main intention of link layer. Here, these are all different protocols here. Here comes to the one by one. We will discuss one by one. Here, what are the 8.23 Ethernet protocol here? What is the 8.3 Ethernet protocol here? The Ethernet protocol consists of a set of technologies and protocols that are used in a LAN, local area networks. Here you will use this kind of protocols in a LAN. Here that means that is a LAN in the sense local area network within a organization. You will establish in the LAN. Here LAN, WAN, uh, wide area network. After that, finally you will have the internet. Here, what about this 802.3 Ethernet? The 802 point Ethernet was first standardized in 1980 by IEEE 8.23 standard. Here, IEEE 8.3 standard defines a physical layer. That means the first they defines the physical layer, it's that converted into link layer. Physical layer and medium access protocol sublayer of the data link layer for wide Ethernet networks. Here, this Ethernet is classified into two categories: that classic Ethernet and switched Ethernet. This is a something about the 802.3 Ethernet. Here, for what is this information here? This is consist of technologies and protocols used in a LAN. Here, other one here is a 802.11 Wi-Fi. Wi-Fi technologies. Here, that means Wi-Fi technology is a part of IEEE 802 set of LAN protocols. Here specify the set of medium access control protocol and then physical layer protocol for implementing wireless local area networks. Here WAN, that means wireless local area networks. Here without wire you will transferring the data. Here Wi-Fi computer communication in various frequencies. The frequencies here you are using the 2.4 gigahertz, 5 gigahertz, 16 gigahertz of bandwidth. Here previously wired network, here wireless network. Here you are implementing, that means Wi-Fi computers. Wi-Fi computer in the sense you are implementing the wireless local area networks. For that purpose you are using the 802.11 Wi-Fi. Here next one here is a 802.16 Wi-Fi max. Here what is the standard Wi-Fi max technology? Here wireless metropolitan. Here that means not a particular organization within a town. You are establishing the wireless metropolitan area networks. Here WAN. Here with the help of this 802.16 Wi-Fi max. Here it's have been developed by a working group of 16 members here. Here this is specializing in point-to multi-point broadband wireless access. Here it's having a single point to multi-point. That is some information about the 8.216. Here 802.15.4 LR WPN. This is also a one type of network here. Here that means it defines the MAC and the physical layer used by here Zigbee. This type of information used by Zigbee 6LO WPN thread. That means double SN. Here Zigbee protocol. That means this number of protocol. Here this standard provides a low cost and low speed communication for power constrained devices. Here this is a simple standard in a link layer. This is a simple standard or protocol. Last one protocol for the link layer here is a 2G or 3G or 4G mobile communication. Here these different types of telecommunication generations. Here that means IoT devices are based on these standards can communicate over the cellular networks. This is a some information about the link layer protocols. Coming to the network layer protocol here. Here, what are the information about the network layer protocol here? Here, responsible for sending the datagram. Here, in the link layer, transferring the message. Here, the particular message from via medium. The message converted here is a IP datagram from the source network to destination network. Here, that is a information. Here, network layer performs some of the operations here. Post addressing, packet routing. Here that means this can be used in a IP version 4, IP version 6 for post identification. You are using the IP version, Internet Protocol version 4. Here IP version 4 and IP version 6 are hierarchical IP addressing schemes. Here, that is a simple information. What is the network layer protocol here? Here, network layer protocol sending an IP datagram from source network to destination network. Here, for coming to the first important one here is a IP version 4. Here, what is an IP version 4 here? The IP version 4 is a internet protocol address. Here, IP address here. What is the necessity here? It is a 32-bit addressing. Here, that means is a numerical label assigned to each device connected to computer network that uses a internet protocol for communication. Here IP address serves two main functions here: host or network interface identification and local addressing. Here for doing this interfacing, here interface identification and local addressing, you will use this addressing. Here this internet protocol version 4 defines a IP address, 32-bit address. For example, nowadays you are for each and every system address is a 168.1, that means 2.3.4 like that, 160